All right. Yeah. Okay. Can you guys see that all right?
Let me see. No, we're not getting that. Hold on a second. Here it is.
Okay. Cool.
Want to get one? We just close our eyes. All right.
All right. Is the size good for everybody? I can go a little bit bigger. All right. Is that okay for everybody? Some stuff is going to go off to the side. I've done my best to keep everything in the window, but if you can't see something you want to, just say scroll right. All right. So first, I'm going to make a couple assertions. Everywhere you see a unit test, and it's I'll get there. Everywhere you see a unit test, it's passing, so we don't have to continually run the unit tests. Just know that those are assertions about what's happening, so we can just trust that they are true. The other assertion I'm going to make, and that's really kind of the topic of the day, is if you were to think functionally and leverage features available to you in object-oriented languages, you would have invented the solid principles yourself for a myriad of reasons, but I think we'll kind of get there. Some of the stuff I'm going to go over may not be familiar, so if you're having trouble understanding, there's going to be like a break in between each step. Just ask a question, but if you think you're maybe there, just kind of give me a little leeway, and I think you might find the answer in the next step. So let's start our journey here. All right, so we're going to do a thought experiment today. If we could constrain our programming to just functions and data records, and promise to not rely on any internal state, that's where we're going to start, right? So think, Haskell or another functional language where essentially what you're always working with are functions or some amplified data record, right? And we're going to use some function composition to make our code readable and easy to kind of break up and compose into new higher level functions. And so let's kind of start with a baseline, okay? How many people are familiar with mathematical notation about f of x goes to y? Everybody okay, familiar with that? All right, so if we have an f of x that gives us a y, right, so it takes in a parameter of x and yields a y, and we have a g of y that returns a z, and then we could say that g of f of x returns a z. Okay, and so when you think about x, y, and z, these are concepts in our code. They're not just like a numeric, 1, 7, and 13 or something like that, right? You could think of x as maybe a domain that we have, right? And we need to look up the customer ID for that domain, and then we can pass that customer ID to G and get maybe a set of services for that user, and that's our Z, right? So these are concepts, and we're just saying to get to our eventual value, given what we have, there's an intermediate step. Is everybody with me? All right, cool. So if we look at that in code, right, so our domain knowledge says if we have a function f of x and a function g of y, right, we would expect that if we passed 1, we would get 4, right, just from our domain knowledge about what the code does, what we expect it to do. We can make this assertion, right? And we can break that down a bit. We can say, okay, well, if I just pass f 1, I expect to get 2, and then if I pass the result of f to g, I expect to get the 4, right? So there's no difference with, this set of statements and this first set where we've composed G with F, okay? So now, if we wanted to alias that behavior and create a higher level function that would say, the concept of we've got a domain, we need to get a list of services, right? We could just say, okay, we've got this new function, H, and it returns a Z when given an X. And internally, it composes G with F. Okay, so we can see that, if we compose it and if we call this aliased function, we get the same results. All right, so right now we're kind of in a very abstract place, right? So let's kind of make it a little bit more realistic in terms of what we would expect. So let's say that Z is a list of dragons, okay? And we want to get this list of dragons, and all we've got is X, a realm ID, okay? And to get there, we're going to have to do some lookups to a database and, get back a list and maybe do some transformations. So, we have this higher level function, find dragons by realm ID, and it will yield our Z, our list of dragons, right? Underneath, there's kind of some minutia about how it gets done, right? And we can look at, so say we've got a condition where we have these dragons that exist on every realm, and then some randomly generated dragons on each realm, right? We wouldn't want to necessarily put our data record in the database for all of the evergreen dragons that exist on every realm and have all those duplicate entries in the database, right? So you could see how somebody might come up with a solution where they get the dragons that exist on that realm from SQL and then maybe concatenate it with some in-memory collection of the ones that are available everywhere, right? And, we can look at kind of some minutia about how it gets done, but really, the only other important part is that right now our collection has 3 dragons. They exist across 2 realms, one realm that we care about, and our test realm where Ben is the only dragon. And so, again, by our domain knowledge, we can make the assertion that if we do find by realm ID, we expect to get 3 back when we look at the main realm. Okay, so I realize I'm kind of expanding, but, if anybody needs to, let me know. I can stop and explain. Okay, so let's add one more layer of complexity, right? So we don't want to just get the dragons that exist on the realm. We want to get the dragons that have been seen recently, right? Recent, that's another concept in our code. So, we could say, okay, well, I've got this find dragons recently. I pass it a realm ID, and I expect to get back again a list of dragons, but now with some more logic that's associated with it, right? We want to actually filter the list that we get back. So we compose all of the dragons, right, with the dragon sightings, a filter function, and some threshold for what we consider recent in our code, right? And, we can see it's just a simple filter statement here, basically saying, if they've been seen since that date. And, again, our domain knowledge says, okay, well, only Niv Mizzet has been seen recently on the server, right? In the realm, he's the only one that's been around. Okay, so at this point, we've got a kind of a higher level function that we want to be able to test. We've got these business rules that are getting more and more complex. So how would we test this, right? We'd have to set up, there's one other important thing, sorry. The sightings, we're actually getting those from Mongo and not from SQL, right? So if we think about how we'd have to test this method, well, we'd have to set up a SQL database locally and a Mongo database locally, and we'd have to fill it with some data that we expect, and we'd have to clean up that data or create a new database for the next test method, and it would just be slow and tedious, and really it's fairly simple logic we actually want to test, right? So, that barrier to entry is going to just prevent us from actually doing the test, right? So, we can see where we want to make this testable. So we've got functions and we've got data records. Well, we're going to have to pass in the functions as a part of the parameters for how to fetch this data. So now our signature becomes find recent dragons, and we pass in a function that will get us the dragons by realm ID, a function that will get us the dragon sightings, and a realm ID, right? And now we could mock those functions in our test structure to say, okay, when given realm ID of the main realm, just return these pieces of data without having to actually connect to a database. But, as we see here, all of a sudden, now calling this find recent, we've got to pass in functions and the actual data arguments that are, important at runtime for how to get it. And we kind of lose some of the simplicity of going in a functional way, right? We lose that higher level function because the caller now has to know about how to get the dragons and how to get the sightings, right? And that's not something we really want to put on the caller just to get testability. So we end up with two categories of inputs, the ones related to how and the ones related to when given, okay? And with object-oriented languages, we get to clean this up a little bit. So wake up, right? Thought experiment over. We actually using C#. We have access to object-oriented principles and, much more importantly, the features of an object-oriented language that let us do things like partially applied functions through constructor arguments, and we'll kind of see how that fleshes out into the simple service model that a lot of us are using today, right? So if we wanted to, create a service or essentially like a func that did this same thing, right? We would pass the arguments related to how in the constructor, right? See, we've got the same set of functions that we expect you to provide and the threshold, so it's easily testable, right? And then we've got the actual logic about how to get the data and filter it here. Okay, so we're calling those functions that we've passed in the constructor to get our data, and now our caller is back to only having to provide a realm ID. So we get kind of the best of the both worlds, right? And an important thing to note about this, we're only trying to abstract away and inject our dependencies, right? Not just logic in general. Okay, so we've got some orchestration logic here, and we've got our actual filtration logic here. And you could make the argument for, well, why aren't you injecting a filtration function, right? Well, this method, its job is to get the dragons that have been seen recently. Some of that is orchestration, some of that is filtration, but neither one of those are dependent on any technologies or any logic that we really want to vary at runtime, right? If we decided that we wanted to test different algorithms, we could inject that filtration function, but there's really no reason to do that until we're at that point, right? So now we can see, okay, well, now we can compose separately how we do the thing and actually doing the thing, right? And if we take that one step further, because if you think about it, right, in isolation, this method up here would do exactly what we needed, okay? However, when we wanted to test the Find Dragon service, we'd need to do this same thing again, right? Get the how of how it's done out into the constructor, and when given, expose just that to this method. Otherwise, we'd start having the same problem where we have all these functions we have to pass in just to satisfy the thing we're dependent on, right? And the importance of this is separating those two pieces of composition out, right? So we can do that by applying the same technique to those services. So we can inject just the contract for the actual call signature and let the minutia about how the constructor arguments are formed for the how happen somewhere else, right? And if we're using something like DI or a service locator pattern, that happens at our composition root of our application. So where we compose the how of our app, we wire up all of our different interfaces to concretes about how to get it done. And what you see here is this starts to look a lot like the code that you're seeing in Boson and in other services that are kind of newer. They're just simple services that inject some dependencies in the constructor and do some work in the method, and they have a single purpose, right? And so you could kind of see how if you start with thinking functionally, right, and you keep it simple, keep it to just function calls with data records, and then kind of migrate into the world of object-oriented languages and notice these features, you would kind of get to the simple services that we're already using, right? But now there are some other problems that pop up that kind of necessitate the solid principles, right? So, and we can see here, this is kind of what we would see in our composition root, right? And this is actually just asserting that it still does the exact same thing that the methods before it have, right? So when we think about solid, all of a sudden we start seeing, okay, so dependency inversion principle, that's like the core of how we're making this a sane way to program, right? We're able to extract out the how into the constructor and inject those so that we get testability, we get the ability to vary the implementations at runtime, so through feature flags and things like that, test out the different algorithms, swap over to a different persistent source. We get a lot of flexibility out of that, just breaking out the composition. We don't have to refactor all those method signatures across our entire app just to make the thing work again. The interface segregation principle, and that bit about separating out the constructor, once you've created the constructor, now you have a partially applied function, right? So you have part of the application of the inner workings of that function happening at an earlier time and aliasing it as this higher level function that you can call at runtime and get some static behavior mixed with some dynamic behavior, right? And so, the interface segregation principle, well, that keeps us from coupling these things, right? If we had one interface and one service with 15 methods, right, and we wanted to swap over just one of them to use Mongo or to use a new endpoint that, the SecureTide crew rolled out, right? We would have to kind of do all or nothing, or we'd have to do a lot of refactoring to make these two things work in the same class together. So the interface segregation principle says, don't mix your peas and carrots, right? Let those things be different, and if through requirements of your app you need a single concrete that actually implements many interfaces, that's fine, but keep the interfaces separate, right? Because the interfaces are the contract by which you're going to do this composition. The single responsibility principle, it forces us to break up complex problems into simple composable problems, right? We take all these different pieces of the problem and break them out into reusable, but more importantly, isolated bits that are testable. And then we can compose those isolated bits together to get our complex business logic. And you can really kind of grok what's happening just by looking at the orchestration layers up top and following those dependency chains down to understand all the pieces of the problem and how you got to the solution, right? So it also acts as a form of documentation about the process by which you get to the solution that you want. And then the open-close principle and the list-off substitution principle, really, that's just about safety, right? We want to be able to do this composition naively. We don't want to have to think about the underpinnings of how the work gets done and whether or not my thing is going to throw a not implemented exception because in this case, it didn't make sense to have this method, so we throw a not implemented exception. Well, right there, that's a list call violation, right? If I tried to use this by its contract and all of a sudden it started throwing an exception for me, that's going to cause me problems. So you could see how all of these principles really make it safe and sane to take this approach to programming. And I think it's a great approach to take because it gives you composability, meaning you can change the order at which things are applied. You can do things asynchronously in ways that simply would be hard if this was one monolithic structure, right? Instead of having to change everything all at once, we can change it a little bit at a time, vary the implementations, and use things like feature flags as a safety net to fall back to the thing we know. And so that's kind of my assertion, right? You would have gotten here by yourself if you just started thinking functionally and then leveraging object-oriented programming. Are there any questions?
Great.
And I'll put this up on my GitHub and send a link out.
Very good, Mitch. Thank you.
Yeah, thanks.
What university are you going to teach at?
That would be the University of Colorado at Boulder.
See y'all later.
You're still recording.
Yeah, I don't know how to stop that.
We're gonna just go to this little. Do you want me to send it, or it's on SharePoint? You can download it from SharePoint.
Okay, cool. Yeah, if you could just let me know when it's up.
Yeah, I'll get it up there. I've got a. There's a machination that goes there. It has to like download link manager.
It's exactly called Comodozo, right?
I don't have any clue what it means.